This conference will now be recorded.
So today we'll talk about LVM. LVM stands Logical Volume Manager. LVM stands Logical Volume Manager.
Can you please share your screen?
In AWS, we have discussed about EBS, Elastic Block Storage. AWS we have EBS, Elastic Block Storage. That EBS, Elastic Block Storage, Linux we call LVM, Logical Volume Manager. So what is this Logical Volume Manager? What is this LVM function? For example, you take Microsoft, you have a D drive or E drive. The drive is 100% full. The drive is 100% full. Is it possible to increase the drive size without loss of data? When my drive is full, is it possible to increase the drive size without loss of data? It is not possible. But it is possible. How? Take the drive backup. Take the drive backup. There is a separate team, backup team. Tell the backup team to take the drive backup. They'll take the backup of the drive. After taking the backup, increase the drive size, format it, then restore from the backup. Let us take, for example, Linux. We have a file system /dev slash /sds7 mounted on /home. My file system /home is 100% full. What's the command to see the disk usage, file system usage, df-h, df-h to see the file system usage. You notice that the file system is 100% full. When the file system is 100% full, no one can create the files, no one can modify the files because of no free space in the file system /home. As a Linux admin, your job is here to increase the file system size. It is not possible to increase the file system size when file system is mounted state or when the file system is active. When we call the file system is active, if somebody working on the file system, any program file open in the file system, then we call that the file system is active. Before you take the backup, you have to unmount the file system first. How to unmount the file system? Emount /home. Why you have to unmount the file system? Why? Because without unmounting, if I'm taking the backup of the file system without unmounting, somebody making some changes in the file system, somebody drawing the amount to ATM card, somebody deposit the amount, somebody doing the money transactions online through Google Pay or Phone Pay, you can't take complete backup. It is not recommended to take the file system backup when the file system is active. So before you take the backup, you have to unmount the file system, then take the backup. It is not possible to unmount the file system when the file system is used, when the file system is being used. So what the error we'll encounter here, file system is busy. Whenever we encounter this error, file system is busy, meaning of that somebody working on the file system or any program file open the file system or any applications are running on the file system, you can't unmount. Then you have to shut down the server to maintenance mode, single user mode. We discussed earlier init yes or init 1. What is init 1? Single user mode, maintenance mode, either yes or 1, both are same. Disconnect all the logged in users, unmount all the file systems, then bring the server to the maintenance mode, run level 1. Why it is called single user mode? Only root user can log in, only admin can log in. No other user can log into the server as long as you are in the maintenance mode. So we can take the file system backup, we can increase the file system, format it, mount it, restore the data from the backup. That is possible, but here this is called offline. Whatever so far we discussed, This is called offline. The meaning of offline, my application is not available to the end user. Users not able to log into my server. Downtime to the application, downtime to the end user. For example, if this file system is terabyte, more than terabyte size, it will take 10 hours, 5 hours, 6 hours to take the backup. So 5 to 6 hours downtime to the application, 5 to 6 hours downtime to the end user. So it is not recommended. You have to take the file system, you have to engage the file system online when logins are active. Engage the file system online when applications are up and running. That is possible with LVM. Without any downtime, without taking the backup, without loss of data, without unmount the file system, I can increase the file system size dynamically online. The meaning of dynamically when logins are active and applications are up and running. That is possible with LVM. Right. This is one advantage of volume management. In AWS also we discussed EBS volume, how to increase the volumes as online without unmounting, without taking the backup. There we call it a snapshot. Snapshots are nothing but a backup. Without taking a snapshot, without taking the backup, how to increase the volume, we discussed earlier in AWS. The same we are going to discuss in Linux. That is LVM. So one more advantage of LVM is, for example, I want to install Oracle database or SAP database where I required 120 GB free space. I required 80 GB, 120 GB free space. But I have more than one hard disk. I have more than one hard disk. In the first disk, second disk, third disk. In the first disk, I have free space of 50 GB. I have free space of 50 GB in the first disk or 40. In the second disk, I have free space of 50 GB. In the third disk, I have free space of 60 GB. All these are free spaces in three different disks. But my requirement is I need a volume, I need a drive, I need a file system with 80 GB or 120 GB. I don't have any hard disk with 80 GB free space or 120 GB free space. They are the free spaces in three different hard disks. Then how we resolve the problem? I need 80 GB or 120 GB. There is no hard disk with free space of 80 GB or 120 GB. It is very simple. As a procurement team, I need a I need a terabyte of hard disk, 1 TB hard disk, 2 TB hard disk. To go for new hard disk, purchase new hard disk. If I purchase new hard disk, wastage of storage, wastage of disk space, without going for new hard disk, without purchasing new hard disk or storage, with the help of this volume manager, what we can do is group all these free spaces. Before we group all the free spaces, create the file system in the first disk. You know how to create the file system, right? Slash del slash SDA 10. Create the file system in the first disk with the free space of 40 gig. Create a file system with free space of 40 GB. Create a file system in the first disk. In the second disk, create one more file system with the free space in the second disk. What is second disk? HDB. HDA stands first disk, HDB stands second disk. In the third disk, create the file system with the free space that is called HDC. You know how to create the file system. So with fdisk command, create the file systems in the first disk with 40 gig free space of 40 gig. In the second disk, create the file system with free space of 50 gig. And third disk, create a file system with 60 GB free space. After that, we are going to combine all the free spaces. What is volume manager? Volume manager nothing but grouping of physical disk. Grouping of physical disk. Combine all these free spaces. If I combine all the free spaces, we got the volume. We got the volume. This volume is 40 plus 50 plus 60. So how much you got? 150. You got the volume of 150 G. That is called volume manager. What is volume manager? Grouping of physical disk. So SDA10, SDB11, SDC12, these are called physical volume. All these are called physical volume. Physical volumes are physical disks, both are same. These are called physical volume. And we created one volume group by combining all the free spaces. So this is called volume group. What is volume group? A volume group is a collection of physical volumes, nothing but collection of physical disks. Physical volumes or physical disks. My name of the volume group, for example, slash dash slash VG00. Slash dash slash VG00 is the name of the volume group. We can define any name as we wish. Assume that slash dash slash VG00 name of the volume group. Now, what is my volume group size? 150 GB. What I feel that I have single disk 150 GB. As end user, what you feel that you have single disk 150 GB. What is the requirement? Your requirement is 80 GB. I can take this 80 GB from the volume and create logical volume. You can create n number of logical volume. All these are logical volumes created under volume. So what are these are called? These are called logical volumes created under volume group. For example, this logical volume, my volume group is 150 gig, my requirement is 80 gig, I can take 80 gig from this 150. The requirement is 120 GB, you can take 120 GB from the volume group because the volume group size 150 GB. You can take 120 GB from the volume group and create the logical volume. So these logical volumes are, for example, slash // VG00 slash VG00 VG00 name of the volume group, LV01 logical volume name, LV01 name of the logical volume, LV02, LV03, and so on. We can create a number of logical volumes from the volume. So this is the concept of right. After creating the logical volume, we need to format it. Like we are formatting the file system, right? Likewise, here also we have to format it. So you know how to format the file system. MKFS or mkfs.ext4 or xfs // vg00 slash lv00 or lv01. Format the logical volume either est4 or xfs. Then mount the logical volume. Mount // vg00 slash lv01. Mount it on slash home. If you create this file system for user home directories, mount on slash home. If you create this volume for Oracle database, create the directory with RDB and mount it on RDB. If you create the file system for Hadoop kind of database, create the directory with Hadoop and mount this file system on Hadoop. This transfer is already discussed. So here I'm mounting on slash home. Now run df-h to see the mounted file system. You'll notice that // vg00 slash lv01 mounted on slash mounted on slash. This is the concept of LVM. Create the physical volume, from physical volume, create the volume group, from the volume group, create the logical volume, then format the logical volume, mount the logical volume. So we are not formatting physical volumes, we are not formatting volume group, and we are formatting only logical volume. You know how to write the data in the file system. So go to mount point, cd slash home, and whatever files I'm creating here, or whatever data I'm installing, a database I'm installing here, the data is going to install in logical volume. This is my file system, right? So whatever files you created in the mount point, this data is going to store in the logical volume. For example, I'm copying some files cp slash etc slash passwd slash etc slash shadow slash etc slash group, all these files and etc directory I'm copying to the mount point slash. So type ls slash home. You can see the files passwd, shadow, and group. Where these files are not in the home slash home. These files are in LV01, logical one. So whatever you write in the logical volume, is it physical or logical? As a end user, you feel that the data in the logical volume is physical, data storing here, but it's a logical, data is not storing here. Whatever you write in the logical volume, this data is going to write in the volume group, because this space we are taking from the volume group. So whatever you write logical volume, this data is going to write in the volume group. Whatever you write in the volume group, finally the data is going to write in the physical volume or physical disk. You can't access physical volume, you can't access volume group, you can access only logical volume. So whatever you write in the logical volume, data is going to write first in the volume group. From the volume group, it is going to write in the physical volume. Assume that if this logical volume is 80 GB, this volume, this logical volume is 80 GB, how data is going to write? Here we have only 40 GB. After completion of 40 GB, first disk, then data is going to write in the second. After completion of first disk, it is writing the data in the second. This is called spanning. This is called spanning. So data will span multiple. For example, there is no volume manager. You're writing the data in the drive, E drive. The drive is 100% full. That gives the error. I can't able to copy the files. My drive is full. The rest of the data will not be copied because of the drive is full. Here data cannot span on multiple drives. Data cannot span on multiple disks. But here, once this drive is full, the disk is full, automatically copy the data in the remaining next hard. That is called spanning. Data will span on multiple. There is the advantage of volume. If my volume is 120 GB, after completion of first disk, then write the data in the second disk. Second disk also full, then write the data in the third. That is the advantage of volume management. Tomorrow, my logical volume is 80 GB is 100% full. So we have a command. There is a command called LV extend. With the help of LV extend, I can increase my logical volume size dynamically online. I told you what is dynamically when logins are active. So what's the command? LV extend. To increase the volume online. When my applications are up and running, when my logins are active, without any downtime. But provided there must be a free space in the volume group. Because if I run the command LV extend, for example, 20 gig, I want to add 20 GB more with LV extend command. All these practicals we'll see later. First, understand the concept. So I want to add 20 GB more. with LV extent, provided they must have a free space in the volume. So as of now, 80 GB already used. How much free space left? 60 GB, 70 GB, right? So I'm going to add 80 GB. It's not possible because no free space in the volume. In that case, take a new hard disk, add to the volume group online. We can increase volume group size online. We can increase classical volume size online. Take a new disk, 1 TB or 2 TB new hard disk. We can add to the volume. Okay. So what is the second advantage? We can increase volume size online. Like so, in one volume group, how many physical volumes we can add in one volume group? Physical volumes nothing but physical disk. So in one volume group, we can add 250 physical volumes. In one volume group, we can add 250 physical volumes. In one volume group, how many logical volumes can be created? In one volume group, you can create 250 logical volumes. We can get up to 250 logical volumes. Like this, we can create n number of volume groups. One application I create one volume group, another application I create one more volume group. The different application we can get different volume groups. In one volume group, we can add 250 physical volumes and we can create 250 logical volumes. Take a physical disk, convert the physical disk into physical volume. Convert the physical disk into physical volume, nothing but it is going to create number of physical extents. In every physical volume, it is going to create number of physical extents. These are called physical extents. We call it as a PE. PE stands physical extent. The default size of physical extent is 4 MB. The default size of physical extent is 4 MB. If you want, you can increase. What this physical volume contains? Number of physical extents. So every physical volume contains physical extents. What is volume group? A volume group is a collection of physical volumes, nothing but collection of physical extents. The volume group also contains number of physical. So these are physical extents. And from the volume group, we are creating logical extent. When I create the logical extent, it is going, sorry, we are creating logical volume. When I create the logical volume, it is going to create number of logical extents. The logical volumes contains logical extents, physical volumes contains physical extents. This is called LE. LE stands logical extent. The default size is 4 Default size of physical extent is 4 MB. The default size of logical extent also 4 MB. Right? Now, writing the data, as I told you that we are writing the data in the mount point. Writing the data in the mount point, data is going to write in logical volume. Writing the data in logical volume, where this data is going to write. The data is going to write in LE. LE stands logical extent, that is 4 MB. Where data is writing in the logical volume in logical extent. Data is writing in logical volume, logical extent. That is called 4 MB. Writing the data in logical volume, logical extent. This data is writing in volume group in physical extent. That means 4 MB. It is writing the volume group in physical extent, that is 4 MB. Writing the data in the volume group physical extent 4 MB. This data is going to write in physical volume in physical extent, that is also 4 MB. That means what? We are mapping We are mapping logical extent 4 MB to physical extent 4 MB. We are mapping the logical volume, logical extent, data is writing in physical volume, physical extent. Writing the data in physical volume, physical extent, also not physical. Finally, data is going to write in the hard disk. In hard disk, where it writes, in hard disk, it is going to write in sector. What is sector size? Sector size is 512 bytes. Finally, the data is going to write in hard disk in sector. This is my sector. Data is going to write in the hard disk in sector. What is sector size? 512 bytes. So how much data we are writing in the hard disk at a time? We can't write directly in the hard disk in sector. We are writing the logical volume from 4 MB. From logical volume to logical extent to physical extent. Again 4 MB. From physical extent again physical extent 4 MB. Finally, it is writing the data in the hard disk in 512 bytes. How much data we are writing in the hard disk at a time? 4 MB data. We are writing the hard disk at a time 4 MB data. How much data we can read at a time? 4 MB data. Writing is 4 MB, reading is 4 MB. That increase the read and write performance. So this is the concept of LVM. Any questions, guys? So tomorrow we'll see the practice.